I just want to give you a remark that once you find the location to displace from A, okay, you can say that I can now displace this force along its line of action. Okay, so this is your resulting force here. You have a negative x component and you have negative y, and it's downward along y, and also a negative x. So your resultant force will be, when you do the summation of both, okay, you will have a resultant force like this. So this is your, let's say, your resultant, okay, when you do the summation of these two forces. Now, this resultant force, if you displace it on its line of action, you don't need to add any couple, because any force, when you displace it on its line of action, you will not change its moment about any point in the space, okay? So once you find just one point at which I can reduce my system to an equivalent force, then you can say, if I displace my force along its line of action, passing by this point, I will not need to add any couple. So you have an infinity of points where you can place your force in a way to have an equivalent system. Okay, here on a practical way, of course, you should intersect the truss. In here, for example, you can or displace it on AB, or you can displace it on this line. On this line, you can just apply it here. By geometry, you can calculate this because you know the resultant force, and from the resultant force, you can determine, if you want, its angle. What is the angle of the resultant force? Let's say with AB, and then you can say, if I displace this force along this line, nothing will change. So I can, if I know theta here, for example, if I know this angle, from geometry, I can find what will be the intersection with this line, okay? And in this way, finding one point of application where I can reduce my force, my system, to a single force, I can find also other points by deduction from this. Or if you want, if they ask you to find the distance along this line, you should repeat the calculation and to find what distance should I displace here. But in this case, if you want to find the distance that you should displace along this direction, it is easier for you to decompose your force like this. Instead of taking inclined x and y, you can take y and x in this way, okay? So this will make it easier for you to calculate the distance to displace, because in this way, when you move along this line, this component will not produce a moment, only this component will do a moment, okay?
Doctor,
Question on this?
I have a question, Doctor.
Okay. So let us, yeah.
Professor, if we do the normal XY projection, we don't take the XY incline,
Yeah.
can you just do one example for one force on a figure?
Yes, look, you can do it, but it will complicate things for you, okay? Why it will complicate things for you? Because if you get x like this and y, it will be x like this and y like this, okay? No, it will be your resultant force. If you follow the figure here, once you get your resultant, هيطلع like x component in this direction, هيطلع لنا y component downward, okay? هلا this system of x and y will be easier to work with if you want to displace along this line, as I said. But if you want to displace along this line, this will make things more complex, مظبوط? Because in this case, when you displace along this line, both will have moment, x and y. You can do it, but it will be more complex. Yani, if you say, I will move this force, okay? If I want to move this force, I will have the moment of the first component and the moment of the second component. and I should add them in order to produce the resulting moment. So instead of doing this, because you know that you want to displace on AB, from the beginning, divide your force into a component along AB and a component perpendicular to AB. Because this will simplify things for you, since by this way, the X component will pass by A and will not produce any moment above. Okay?
Okay, thank you.
Okay. Here, it's another problem, same concept, okay? So please, try to practice with this problem. Replace the force system acting on the frame by an equivalent resultant force and specify where the resultant line of action intersects member AB measured from point A, okay? So it is the same style of questions. I have a structure, I have several forces acting on it, and I want to reduce the system of forces to one single force. So as usual, the first step, I choose a point, I select a point, I reduce at this point my system to a X component and Y component, and then they want me to specify where the resultant line of action intersects member AB measured from point A. So they mean if I want to have just a single force, I want to displace it on AB. I want to find what should be the distance that I should move my resultant force on AB in order to get an equivalent system. So here, the methodology is the same. First step, I sum of forces I do summation of forces to get FRX and FRY. So as you can see here, I can reduce to my force to X components. The X component is positive because here you have 35 sine 30 plus 25 along X. The Y component is downward because I have 20 downward plus 35 cosine 30 downward. So I can get the resultant Y component and the resulting X component. Second step, I do sum of moments about A. When I do sum of moments about A, I add moment of all forces about A. So here, for example, for this force, it's inclined. The Y component is doing a moment. The X component is not, okay, because it's passing by A. So I do 35 cosine 30 times 2. I would choose the clockwise as positive, plus 20 times 6. And finally, pay attention for this force. This force is trying to rotate your structure about A in the counterclockwise direction. So it's a negative moment. It's minus 25 times 3. So when you do the resultant, okay, you will get if the resulting moment is clockwise or counterclockwise. So here it seems that it is the resulting moment is clockwise if you do the calculation. So now, once I reduced my system, I say how to displace, what distance should I displace on AB in order to have an equivalent system with one single force. So again, same method. I say if I displace on AB, the X component is not producing any moment because it's passing by A. So the only contributor to the moment will be FR1. And what is the distance to displace my force in order to get an equivalent moment? I write that M resultant at A, MR at A should be equal to FRY times D, and then I can find D, okay? Now, once you find the distance D, then you reduce your system to a single force, okay? But from here, from this result, you can deduce what is the point I can put my force on BC in order to obtain an equivalent system. How to do this? It's very simple. You say, if I displace my force on its line of action, I will not change anything. So once I find one location to place the single force at in a way to have the same effect on A, I can say that if I displace this force on its line of action, nothing will change. So once I get my result here, the intersection with AB, I can deduce what is the location on BC. If I want to place my force on BC, what should be its location to just have one single force without the need of adding a couple. So here, from geometry, you can deduce the location because you know the inclination theta of your force. By doing tangent, theta is Fry over Frx, an absolute value. Once you get theta, you say that if I extend my line of action, if my force is applied here, it will just produce the same effect, because if I displace a force on its line of action, nothing will change. Then you will say, I found here that the distance is d, and of course I know the length of AB, so I can deduce that this distance here is L minus d, okay? And then once I find this distance here, I can deduce what is d prime here. So d prime here is calculated simply by saying that d prime over L minus d is equal to tangent of theta. Okay, and that's it. So these problems all, we have done several problems. The same method is repeated. So just if you understand once how to do it, you can solve any problem of this sort. Okay, any question on this? Do you have questions for the exam? Okay, so we continue next time. Okay, bye guys.
Thank you, Doctor.
Thank you, doctor.
Thank you, doctor. Bye.
Thank you, doctor.